A model for the radioactive decay of a form of iodine is given by this equation here, m equals m naught times 2 to the power minus t over 8. The mass of the iodine after t days is m grams. Its initial mass is m naught grams. Use the given model to find the mass that remains after 10 grams of this form of iodine have decayed for 14 days. Giving your answer to the nearest gram. A mass of m0 grams of this form of iodine decays to m0 over 16 grams in d days. Find the value of d. After n days, the mass of this form of iodine has decayed to less than 1% of its initial mass. Find the minimum integer value of n. So I've got the question summary form here, so let's have a look at it then. Part A, first of all. So let's have a look at this first part. 10 grams has decayed for 14 days, so the mass that results is the initial mass was 10 grams. 2 to the minus t, 14, minus 14 over 8. So let's just tap that in the calculator then. Simple as 10 times 2 to the power. And we can put minus 14 over 8 if we wish, or we can simplify the fraction. 2.973. 2.973. So we need to work it out, find the mass to the nearest gram. So m equals 3 to the nearest gram. That's part A. Part B then. m0 decays to m0 over 16 in d days. Find d. So again we need to write the formula down. Is equal to m0, 2 to the minus t over 8. M decays to m0 over 16, wasn't it? So let's put that in for the value of m. Okay, this decays to the mass, this. So what does t equal? Well, the m0s will cancel. And we get 1 over 16 is equal to 2 to the minus t over 8. If we invert both of them, so the 16 can be switched upside down, and if we flip this upside down, we can flip the index basically. Simple as. Now 16 can be written as 2 to the power 4, and that's equal to 2 to the t over 8. So when does t over 8 equal 4? Well, that would be when t is 4 lots of 8, which is 32. So t equals 32. So d equals 32 days in the this part of the question. Find d. There we go. Part C now. So the next part. After n days, the mass has decayed to less than 1% of its initial mass. Find the min value of n. So 1% of its initial mass is 1/100th of m, isn't it? That's 1%, or 0.01 lots of m0. That will equal m0 2 to the minus t over 8. So this would be when it decays to 1% exactly, and we can find t for that value first. So cancel by the m0, 1 over 100, so flip that upside down, is equal to 2 to the t over 8. So then that tells us then that take the logs, so I'm going to basically write the equivalent of this equation in log form. So the 2 swings down to be the base number, log 2 of 100. And then once the 2 swung down to be the base number for the logarithm, it's just t over 8 is the index, isn't it? Moves down to ground level. So that tells us what t is. Move the 8 to times and read from right to left. 8 log 2 of 100. So let's tap that in the calculator then. 8 times log 2 of 100 equals 53.15. Okay, there's the time. So that was the time for it to get to 1%. It's going to take just over 53 days. So For it to go below 1%, we need to go to the next day along. So it's 54 days.